So hello everyone, let us solve another lead code question, that is find all groups of farmland. So let us read the problem statement. So you are given a 0 index m cross n binary matrix land where 0 represents a hectare of forested land and 1 represents a hectare of farmland. Now to keep land organized, there are designated rectangular areas of hectares that consist entirely of farmland. Now these rectangular areas are called groups. Now no two groups are adjacent, meaning a farmland in one group is not 4 directionally adjacent to another farmland in different group. Now land can be represented by a coordinate system where top left corner of land is 0, 0 and the bottom right corner of the land is m-1, n-1. Now find the coordinates of the top left and bottom right corner of each group of farmland. A group of farmland with top left corner at R1, C1 and bottom right corner at R2, C2 is represented by the 4 length array R1, C1, R2, C2. Now we need to return a 2D array containing 4 length array described above for each group of farmland in this matrix land. Now if there are no groups of farmland, return an empty array and you may return answer in any order. So the question statement looks a bit confusing. So let us understand with the help of this first example. So this is the first example and this is the matrix that they have given. Now here 1 represents the group of farmland. So 1 represents farmland and 0 represents forested land. So we don't have to deal anything with zeros. Now they have said that no groups, or like they have given the definition of groups actually. So these to keep the land organized, they have designated rectangular area consisting entirely of farmland. These rectangular areas are called groups. Now these ones and ones, like these particular ones is called one group. Now this is another group. Now they have said that no two groups are adjacent to each other in 4 directional way. Now you might say that these both are adjacent, but these are diagonally, so that doesn't mean that they are adjacent. We need to check only these 4 directions, not diagonally. So this is the statement that they have given, and we need to return the top left corner and the bottom right corner of these groups. So this is the simple variation of the previous 2 questions that we have seen. We need to just return the number of groups or number of island in that case, but here we need to return the top left corner and the bottom right corner of these groups. So we will simply use a DFS, depth first search, and we will find each of the group in our entire matrix. Now the problem here is that we don't need to count the number of groups. We don't have to count the number of groups. Instead we need to return the top left and bottom right coordinates of these groups. For example, this is the group that we are seeing, so I need to return this top left corner's coordinate and bottom right corner's coordinate. So what is this coordinate? Top left corner is 1, 1 and bottom right is 2, 2. And you can see that this is the answer that they have presented. Now if I talk about this group, here top left as well as bottom right is same. So here it would be 0, 0 and 0, 0. So they have returned the same as we have seen, 0, 0 and 0, 0. And in the end we have returned this output. But the question is how we can find the top left corner and the bottom right corner. Now if you simply observe one thing, the top left corner, let me write it here, the top left corner is nothing but minimum of, now I am representing like in 0 based indexing, so this representing the row number and these are representing the column number. Now top left corner is the minimum of all the rows present in that group, so it is minimum of rows as well as we need to see the column as well. So it is minimum of all the rows and all the columns present in that group. Now if we take this case, now here we have coordinates of all the 4 ones as follows. So first coordinate is 1 comma 1, the second this one is 1 comma 2, the third one this is 2 comma 1, and the fourth one is this, what is this, 2 comma 2. So I'm writing it here. So these are the 4 coordinates of this group, and we need to take the top left corner. Now I have said that top left corner is the minimum of all the rows and minimum of all the columns. So amongst all that, what is the minimum of all the rows? So here rows are 1, 1, 2 and 2. So the minimum is 1 itself amongst 1, 1, 2 and 2, and minimum of all the column is 1, 2, 1 and 2. So amongst all these 4 coordinates of the columns, what is the minimum column? That is 1. So 1 comma 1 is the top left coordinate, and this is the top left coordinate according to our answer also. So for the top left coordinate, we just need to keep the minimum of both row as well as columns. And now talking about the bottom right corner, so let us see that for bottom right corner, for the bottom right corner, we can observe one thing, that it is nothing but maximum of all the rows comma all the columns. Now again write all the 4 coordinates. It is 1 comma 1, it is 1 comma 2, it is like 2 comma 1, and it is 2 comma 2. Now maximum of all these is nothing but 2, and maximum of all these is nothing but 2 again. So 2 comma 2. So our bottom right corner would be 2 comma 2, and we can see here also it is nothing but 2 comma 2 according to the output also. So we will use a simple DFS and we will find each and every group. Now amongst each and every group, we will maintain one R1, one C1. Let me erase this. We will keep one R1 and we will keep one C1, and we will store minimum of all the R1s and C1s possible, and we will also contain R2 and C2, which will contain all the maximum of all the rows and columns. So there is just a slight change. We will just before iterating doing a recursion of DFS, we'll just update our R1 and C1 as the minimum of all the rows and columns, and for R2 and C2 we will replace it with the maximum row and column. So we'll just use a simple DFS function and just make some slight changes in it. So let us write the code now for better understanding. So let us write the code now. So first we will define the number of rows and number of columns. So m is the number of rows, so it will be land dot size, and n is the number of columns, so it is land of 0 dot size. So we have declared m cross n, and we will now keep an answer matrix which will store all the bottom right and top left coordinates. So answer, and we will use a DFS function. We will first make a visited array, because we need to keep track of all the ones that had already been visited. We have seen in the previous videos as well how we use simple DFS function to iterate the entire map. So we'll make one visited array or visited matrix, and it would be of same size, m cross n. Now we need to iterate on the entire map. So what we will do is, now what we can do is we will initialize R1, we will initialize C1, we will initialize R2, and we will initialize C2 with R1 equal to I for now, C1 equal to J for now, C1 equal to J for now, R2 equal to again I for now, and C2 again equal to J just for now, and we'll keep on updating in our DFS call. Once this DFS is completed, we will get the top left corner. So we will push them into our answer. So what is the top left corner? It will be the minimum of all the row and column. So it will be represented by R1, C1. And we will also get the bottom right corner, which will be the maximum of all the rows and columns. So it is represented by R2, C2. Now after iterating to the entire map, we'll just return our answer. Now let us write the DFS function now. So before that I need to pass the parameters. So it will be land visited I, j, m, n and m, n, and I need to pass this R1, C1, R2, C2 as well. Now I just need to write this DFS function. Now I'll just pass on the parameters. It is land and now it is visited. Also I, j, m, n and all the R1, R2, C1 and C2. So it will be R1, C1, R2, C2. So I have declared our R1, C1, R2 and C2 here. So let us write this DFS function now. So first we need to write the base case. So if we get out of the boundary of the map, so this is one base case, so we'll write that first. So this is for getting out of bounds, and if we are moving to a particular forest land which has already been visited, that means it is equal to 1, or we are visiting a forested land, so we don't need to check anything in that region. So if we are encountering any 0, that means it is a forested land. If we are visiting a particular farmland which has already been visited, so we don't need to check that again, or we are going out of bound. So in all these conditions we need to return from our DFS call. Now that means if I am not returning from my base case, that means I am present on a particular farmland which has not been visited. So I need to make that visited first, and then I need to call DFS in all the 4 directions. Now before calling all the DFS in all the 4 directions, I need to update my R1, C1, R2 and C2 before making a DFS call. Now how will I update my R1? It should be minimum of R1 and the current I that I am currently iterating on. Similar way, C1 should be the minimum of C1, j, which I am currently present on, and for R2 and C2 it will be maximum. We have seen this through the example how we are getting this minimum and how we are dealing with this maximum. So we are getting top left corner from here and we are getting bottom right corner from here. Now we will just make a DFS call. Now we can go in 4 directions, and I have first M, then N, then R1, C1, R2, C2. Now all the parameters will remain same in all the DFS. Just one thing is that we need to change the directions in which we are going. So one possible direction was I plus 1, j, one can be I minus 1, j, one can be I, j plus 1, and one can be I, j minus 1. So let us see again what we are doing. I have initialized the M as row, N as columns, and I am making one answer array which will store the top left and bottom right coordinates. I have made a visited matrix, and then I am iterating through this entire map. Now before iterating, I need to initialize my top left coordinates as I, j for now, and bottom right coordinates as I, j for now, and I'll keep on updating this during my DFS call. Now when we are writing this DFS call, first is the base case. One is for out of bounds, one is for already been visited, and one is for forested land. Now in all these conditions I don't need to check anything, I just need to return. Instead, I need to make this farmland as visited, and I'll need to update my top left coordinate and bottom right coordinate as minimum of all the row comma column, and bottom right coordinate as maximum of all the row comma column till now. Now I need to check in all the four directions. What are all the four directions? I plus 1 comma j, I minus 1 comma j, I comma j plus 1, and I comma j minus 1. Now after iterating through this entire map, we will get our answer matrix, which will contain all the top left corners and the bottom right corners coordinates. In the end, we will simply return this answer. And now let us see if this works on sample test case. So it is giving error, so we need to write push back here. So let us see. So it is giving us the wrong answer. What is this? So we did some mistake actually. So we forgot one condition, that we need to make the DFS call only when like we are standing on farmland which has not been visited. So we forgot to write that condition. If we are standing on farmland, then only we need to take its bottom right coordinate and top left coordinate. We don't need to take coordinates of forested land. So we need to write this condition if particular land of I comma j is 1, as well as which is not been visited till now. So we need to write this condition, then only our code will work. So we forgot to write that condition. And in that case only we need to write this, we need to do the DFS call. And in that case we will push all the like the top left and bottom right coordinate. So why we have written this condition? So let's see that, because we need to take the top left corner and bottom right corner of only the farmland, not the forested land. Before writing this condition, why it was giving us the wrong answer? Because we were considering the forested land also. So we need to consider only the farmland. So what is a farmland? A land of I comma j which is representing 1, as well as it should be not visited. If it has been already visited, that means we are if it has been already visiting, then again we are visiting it. That makes no sense, and it will get into an infinite loop. So a farmland which is not been visited till now, then only we will make a DFS call, otherwise don't. So I think this code is correct now. Let us try to submit it. So yeah, it works fine on sample test case. Let us submit if this works fine or not. So yeah, code got accepted. Hope you learned from this video. Thank you.